You're listening to
Hope FM.
The Sound.
103. Connecting communities.
Good evening to your fellow listeners, and good evening to the people who brought me here, my fellow learners in their respective homes. So today I'm Mr. Nkumbi, as our host has already told you. Today we're going to discuss functions and graphs from grade 11. This is what we are going to discuss today. The topic of the day of this evening is functions and graphs. Now, before I can discuss or go deep into this, I would love to give you an overview of today's or rather this evening's lesson. Now, part one of our lesson will be looking at the structure of the topic in the final examination. That is in the standard exam, be it your prelim or your final exam, national one. Part two of our lesson will be looking at what is it that is the most important thing to know when you're dealing with functions and graphs. And then part three, now we'll be shifting from grade 10. I'll be telling you a little about shifting from grade 10 to grade 11 and explain the parameters or the variables in these particular graphs. And then part four, we'll be looking now at the most commonly asked questions in this topic of functions. That is your low order questions. And then part five would be looking at the complex asked questions in this topic of functions. That is your middle order to high order questions. Now, like I said, in part one, we are dealing with the structure of this topic in an exam. Now, functions and graphs are part of paper one scope, meaning you'll find them in each and every maths paper, but it should be paper one for as long as it is in your final or prelim exams. They are found in questions 4, question 5, and question 6 in the exam paper, meaning in your final paper, you are going to find this topic in question 4 and question 5 of paper 1. If it extends, it will extend to question 6. Now, the mark allocation of this topic. The mark allocation ranges between 43 to 47 marks. But then that is when we include part of functions which we call the inverses, which we should have or we will be learning about when we're in Matric. Remember, in grade 10 and in grade 11, we only learned about graphs and functions. Now, on this topic, when we get to Matric, we add inverses. So I'm saying then, if we take what we learned in grade 10, grade 11, and then add inverses, which we learned in grade 12, your marks in a national paper can range from 43 to 47 marks. So it's quite a lot. It's quite a lot. It can make you to pass if you really understand and master this particular topic. Now, when you add this 43 and 40, or let me say on average 45 marks to the 24 marks of algebra, which Mr. Moklong took you through, it shows that you can pass paper 1 with level 3. So it's quite important for us. It's quite important for us to understand this topic. Now, you cannot understand this topic, or rather, you cannot master this topic if you do not have the good foundation on algebra, which is your question 1. Now, but today we're not going to look at inverses. We'll only be doing revision of graphs and functions, which we learned in grade 11 and in grade 10. Now, let us proceed. I said that part 2, we're going to have to look at what is it that is the most important when you are dealing with this particular topic. Now, the most important thing to know when you are dealing with this topic, it is that there are 4 different types of graphs or functions, which we learned in grade 10 and grade 11. The first one, it is your parabola, also called quadratic graph or quadratic function. The second one, it is your straight line. The third one, it is your exponential graph. The fourth one, it is your hyperbola. That is the most important thing to know, that we are having 4 types of graphs or functions, namely parabola, straight line, exponential, and hyperbola function. Now, how do you differentiate between these functions? Because obviously you have to know to differentiate, because now there's also a part of having to draw one of these or 2 or all of this. So then you have to know the difference in order for you to draw and for you to know what is it that you are dealing with. Okay, now the difference will be in the equation that is given to us and also the shape. So it's quite important for us to know the shape. Now, when you go back to grade 8, 9, 10, and even in grade 11, we dealt with the straight line. And then we said that the standard form of a straight line graph is y is equals to mx plus c. So remember, the equation of a straight line is y is equals to mx plus c. So then your x should have a coefficient which is being multiplied with. Then if you have that form of y is equals to mx plus c, then you know that this one is your straight line and not parabola, not exponential, and not hyperbola. Remember, straight line can be a vertical line going from upwards to downwards or from downwards to upwards. It can be a horizontal line from the left to the right, or it can be inclined, as in when you go from your left to the right, it's going up, or when you go from your left to your right, it's going downwards. That I'll explain later on. Okay, straight line is having a standard form of y is equals to mx plus c. I'll also explain the variables in the parts that are to come later on. Exponential graph. Now, what is the difference? How do you know that you are dealing with an exponential graph? An exponential graph, you are going to have a base meaning any number, and then that number will be raised to an exponent of x. Whenever you see a number raised to an exponent of x, then you know that you are dealing with an exponential graph. Straight line, remember, you are having a number that is multiplied by x. That number, remember, it's your gradient. We said in the standard form, it's called m. Now, in an exponential graph, how do you know that you are dealing with an exponential graph? When you are having a number and then it's raised to the power of x. The standard form which we learned in grade 11, it was 1 to a to the power of x all plus. So then the difference would be in an exponential graph, x exponent, whereas in a straight line, x is being multiplied by a certain number. Now, shape-wise, an exponential graph will come to the shape be a curve. Whereas, remember, it is just a line, it's linear. So, but then an exponential graph, it is a curve. When you look at it from the left to the right, it's either going to go upwards, curving upwards, or it's going to curve downwards. So then, an exponential graph, it's a curve, whereas a straight line, it's just a line. So, I only hope that we are still together on this one. Parabola, also called quadratic. Now remember, in a straight line, our x is multiplied by a number. In an exponential graph, our x is an exponent of a certain number. Now in parabola, how do you know that you are now dealing with parabola and not the two that I've already discussed with you? Our x is not an exponent on this one, but our x is a base, which is raised to the power of 2. So now our exponent is 2. Once you see x being raised to the power of 2, then you would know that you are dealing with parabola and not an exponential graph. But then if x is an exponent of a certain number, then you know that you are dealing with an exponential graph. Parabola, of that can be 3 and then x, that x being raised to the power of 2. Then you would know that you are dealing with parabola and not exponential graph. The difference is with an exponential graph, x, it is an exponent. But if parabola or quadratic, 2, it is an exponent to that one. Shape-wise, a parabola, it's like a rainbow. You remember a rainbow? Parabola, it's like a rainbow. It's like an arc. It's like an arc. Whereas an exponential graph, it's a curve going either upwards or downwards. Parabola, it's a curve going upwards, then reaches what we call the maximum point, then downwards. As an example, a classical example of that one is a rainbow. It can also come from upwards, going downwards, and then upwards again. So a rainbow that is facing the sky or a rainbow that is facing the earth. Now, the fourth one, I hope we're still together. The fourth one, hyperbola. How do you know that you are dealing with a hyperbola and that we have already discussed? Now, remember these graphs have an equation. So then if your equation is y is in the standard form of y is equals to a all over x minus p, and then the whole of that you add q, then you know that you are dealing with a hyperbola. So then an equation of a standard hyperbola will have a operation of division, meaning it will have a ratio. And then your x, quite importantly, because then our x tells us what graph are we dealing with. Your x will be part of the denominator. An example of that can be y is equals to 2 all over x minus 1, and then the whole that you add to 2. Hyperbola, when you see that you are having an expression of a ratio or a division expression, and then x is part of the denominator particular expression, then you know that you are dealing with hyperbola. So you can just do a quick overview of that one. Straight line, standard form, y is equals to mx plus c. Our x is being multiplied by a constant, by a certain number. Then if x is multiplied by a certain number, it's a straight line. Shape-wise, straight line is a line like, you know. And then it can go upwards, downwards. It can go vertically downwards. It can go horizontally from the left to the right, or it's inclined upwards or inclined downwards. Exponential graph, when you see the number raised to the power of x, then you know that you are dealing with an exponential graph and not a straight line. Parabola or quadratic. See that your x is being raised to the power of 2. An example can be 2 multiplied by x, and then that x raised to the power of 2. And then the whole of that, then you would know that is a parabola. So parabola raised to the power of 2. X is being raised to the power of 2. Hyperbola, I said that you look for an expression. Now, when you see an expression, meaning when you see a division operation in your equation, then x is part of the denominator. You know that you are dealing with hyperbola. Shape-wise, hyperbola, it's like you are having two parabolas, which are images of each other. But this parabolas, we call the quadrants. Remember, in grade 10, we learned that there's quadrant 2, quadrant 3, quadrant 4. Those who don't remember, just imagine if your window at home had your window frame at home had 4 window panes. So then the first one on your top right would be quadrant 1, and then top left quadrant 2, bottom it would be quadrant 3, and then quadrant 4. So if the shape of the hyperbola, you should have 2 parabolas which are images of each other, either in quadrant 1 and 3 or in quadrant 2 and 4. So I would hope that fellow learners, you are still with me, because now it's important. You can have an equation. For as long as you don't know what equation does, it's that one, then you won't be able to proceed. You should be able to now differentiate these equations to say this one is one of hyperbola, that one is the one of parabola, that one is one of exponential, or that one is the one of straight line. Now, part 3. Remember, I said that part 3, now that we are done with the most important thing, which is to differentiate in between these 4 graphs. Part 3, it is to explain the parameters or the variables for each graph, starting with a straight line. Straight line, the standard form, when we are in grade 11, we say it is y is equals to mx plus c. If I can repeat that one, y is equals to mx plus c. And I said that a straight line is a line joining 2 points. Yes. Now, the standard form of a straight line is y is equals to mx plus c. And just to add, when we're in grade 11, we would move the straight line or each and every graph up and down, only up and down. Our knowledge of functions was limited to movement of up and down. But when we are in grade 11, we add again having to move from the left to the right, and then we add to the movement of up and down. So it's quite important to remember that one. Hence now I'm saying the standard form, because when we're in grade 11, we would have learned that we can be able to move them from left to right. The standard form of each and every straight line which can move or which has already moved up and down, left and right, it is y is equals to mx plus c. Now what is this m? This m, it is a gradient. And in a question paper, at times it is given to us. At times it is not. Now, y is equals to mx plus c, if I might remind you again. M is a gradient. And then we say, when m is positive, meaning when it is bigger than 0, example of that, it's any number is bigger than 0. Our straight line will always increase, guys. When m is positive, our straight line is going to increase. I mean, when you have an equation like y is equals to 2x plus 5, you see, what is multiplied by x? It is 2. And it's positive. So then the straight line will always increase. What does it mean when we say a straight line increase? It means then when you look at it from the left to the right, it is going upwards. When you look at it from the negative x values or the lower x values to the higher x values, it is going to the right. But then when m is negative, the straight line will decrease. Meaning when you look at it from the left to the right, it's going downwards. The y values decrease. When m is negative, an example of that one can be y is equals to negative 4x minus 10. The gradient is negative 4, so the straight line will decrease. Remember, the standard form of a straight line is y is equals to mx plus c. Y is equals to mx plus c. And then I said variable m stands for the gradient, also called the slope of the graph. When m is positive, our graph will, our straight line rather, will increase. When m is negative, our straight line will decrease. So if m is a negative number, when you look at that graph, it is going to decrease. Like when you look at it from the negative x values to the positive x values, or from the lower x value to the higher x value, the y values will decrease. Now, the second variable which I need to explain to you, c. What is c on the standard equation of y is equals to mx plus c? C, it is the y-intercept in a straight line. It stands for the y, or rather it represents the y-intercept. So then if you are having an equation like y is equals to 2x plus 8, the value of gradient is 2. Then you know 2 is positive, it's going to increase. But then remember the equation was what? Y is equals to 2x plus 8. So then c is 8. And then I said that C represent y-intercept. So it would mean that as that straight line increases, it will cut your y value or your y-intercept at positive 8. Okay, now let's take the equation y is equals to negative 4x plus 2 as an example. Now, negative 4 stands for m because it is the number that is being multiplied by x. So then it means that you are going to have a decreasing straight line. It's going downwards. And then that negative 4x is added by 2. So then as it decreases, it will cut the y-intercept at 2. It will cut the y-intercept at 2. Another example, negative y is equals to negative 3x minus 1. Y is equals to negative 3x minus 1. The value of m is negative 3, meaning the straight line will decrease. The value of c is negative 1. It means then as it decreases, it will cut the y-intercept at negative 1. I hope that I'm clear in terms of explaining variables when we're dealing with a straight line. Now, coming to the exponential graph. The standard form of each and every exponential graph. Y is equals to a raised to the power of x. And then, now we're having y is equals to a to the power of x. And then that a to the power of x add q to it. So y is equals to a to the power of x plus q. Take note that it's not x plus 2 plus q, but it is the whole of a to the power of x, and then you add q to it. Now, what does a represent? A would tell us, or it represents the shape of the exponential graph. Remember I said exponential graph, it is a curve. It's that one which takes a curve. Now, if a is bigger than 1, our exponential graph will increase, meaning you'll draw it from downwards and then it will go upwards, as in when you start from the negative x values to the positive x values. So when you look at it from the negative x values to the positive x values, it will go upwards. It will start with a horizontal movement and then takes a curve, and then it goes upwards, But now, when I said that when a is bigger than 1, the exponential graph will increase. When a is bigger than 0 but less than 1, and an example of that can be 1 divided by 2, which is 0.5. It's bigger than 0, yes, but it's less than 1. Our exponential graph is said to be decreasing, meaning when you start from the negative x values, that graph will be up there. But then as in when you throw it, it comes downwards and then takes a curve and then it goes all the way. So then if a is bigger than 1, example of bigger than 1, it's any number that is bigger than 1 that you can think of, 2, 4, 6, 5, and so on. Our exponential graph will increase. An example of that can be when you have y is equals to 2 to the power of x. Y is equals to 2 to the power of x. Now, our 2 is being raised to the power of x. Because 2 now is bigger than 1. Then you must know that you are dealing with what we call an increasing exponential graph, guys. But then, let us say you are having an example like y is equals to 2 divided by 5, close bracket, all raised to the power of x. 2 divided by 5 is bigger than 0, yes, but it's less than 1. If it's less than 1, but bigger than 0, our exponential graph will start from upwards and then it will go downwards as it takes the curve. So the value of a, when you are dealing with an exponential graph, it tells you, or it represents the shape of that exponential graph. And the condition is for it to increase, A must be bigger than 1. For it to decrease, remember that one. A must be bigger than 0 but less than 1. I hope that we are still together. Now, coming to explanation of Q. Because I said the standard form, remember, is y is equals to a to the power of x. Add the whole of that to Q or by Q. Now, Q, it represents what we call, remember, this we dealt with it when we were in grade 11. It represents what we call the horizontal asymptote. It represents what we call the horizontal asymptote. And then we draw this horizontal asymptote from the left to the right. And when you draw the horizontal asymptote, it's a horizontal line from left to right. When you draw it, we use dotted lines in an exam or in a test. So then if, for an example, you have 2 to the power of x, and then all, meaning that expression, you add it by 2, then you are going to go to 2, where at your y values. And then when you reach 2, you are going to draw a horizontal line from the left to the right. From the left to the right. And then that horizontal line, it must be dotted. Remember, it must be dotted. So then if you have an equation like y is equals to 3 to the power of x, and then all minus 9, then you'll know that you are going to go to minus 9 and then draw a horizontal line across that line, negative 9, where in your y intercept. And then that horizontal line which is dotted, it will be your horizontal asymptote. Remember, by definition, we say that a horizontal asymptote, our graph or our curve, cannot go beyond it. So then, if you are having, for an example, it must be clear this one. If you are having 2 to the power of x, all minus 3, you are going to go to minus 3 and then draw a horizontal line at y is equals to minus 3. And then that horizontal line, remember, it's dotted lines. And then your graph, because now it should increase, it must be above. It must be above your asymptote, because now this one is a positive exponential graph. Quite importantly, please do not please do not forget that one. A curve or a graph must not touch this dotted line, because now this dotted line, we call it our horizontal asymptote. So it must be above or it must be below. It will depend on whether you are dealing with a negative or a positive graph. Please, this content, we have already dealt with it when we were in grades 10 and 11. So do go through the stuff on your textbooks about this one. So then another example, let us say we're having y is equals to the bracket of 1 over 3, close bracket, and then the whole of that, you raise it to the power of x, and then you minus 2 to the whole of that. So it's y is equals to the bracket of 1 over 3, all raised to the power of x, all minus 2. So then, because 1 over 3, it's the value of a, and it's bigger than 0 but less than 1, we know that our graph will decrease. And then for the value of q, we're having negative 2. So that's our horizontal asymptote. So we're going to go to that negative 2, draw a horizontal line at negative 2, meaning a line from the left to the right, which is dotted lines. Ne? Remember that one. And then our graph will decrease from, it will come from upwards and then downwards. But as it reaches that y, or as it approaches y is equals to negative 2, where it's our horizontal asymptote, it will just go parallel and close to our horizontal asymptote, but it won't touch or go beyond that y is equals to negative 2. It will just continue going parallel to it, and then at the end would just put our arrow to show that the graph will continue going parallel and not touching or going beyond our horizontal asymptote. Hyperbola. Remember, as I was explaining, I said the standard form of hyperbola is y is equals to a, and then that a you divide it by x plus p, and then the whole of that expression you add q to it. And then I said that hyperbola, it's like, you know, when you take two parabolas which are mirror images of each other. Now, what does a represent in the formula of a divided by x minus p all plus q? A represents the shape. Now, in terms of this shape, we say now, if a is bigger than 0, remember, what does it mean to say now you are bigger than 0? It means that you are positive when you are a number. You are going to draw your hyperbola curves on quadrants 1 and quadrant number 3. Do not forget that one. If a is bigger than 0, you are going to draw your hyperbola parts on quadrant 1 and quadrant 3. And they should be symmetrical, or they should be mirror images of each other. If a is less than 0, less than 0 means you are negative when you are a number. You are going to draw the parts of your hyperbola on quadrant 2 and quadrant 4. If a is less than 0, you are going to draw the parts of your hyperbola on quadrant 2 and quadrant number 4. So then a, as in exponential graph, when we are in hyperbola, it also tells us about the shape. But now, here, we don't talk about increasing and decreasing as yet. Rather, we say a, because now we're laying the basic foundation and we're doing revision from grade 11. A represents the shape, in a sense that when a is bigger than 0, you draw your hyperbola parts. Remember, I said hyperbola, it's like two parabolas which are mirror images of each other on quadrant 1 and quadrant 3. When a is less than 0, on quadrant 2 and on quadrant number 4. What does q represent? As in exponential graph, q also represents the horizontal asymptote. Remember, in grade 11 and in grade 10, we learned that hyperbola also have horizontal asymptote. And don't forget, a graph will never touch or go beyond or across your asymptote. So then q, variable q on hyperbola, or on the standard equation of hyperbola, it represents the horizontal asymptote. This one should be clear because now we have another variable which is p, and this one, it represents the vertical asymptote. So vertical means you go from downwards straight to upwards all the way. Horizontal means you go from left to right. So don't confuse the two. Q, because now in an exam I've seen many of my past learners having confused the two. If I may repeat this one, Q represent horizontal asymptote. Q represent horizontal asymptote. It's a line, dotted line, which goes from left to right, depending on its value. P represent a vertical asymptote. It goes from downwards to upwards. An example of that one, guys. Now, let's say we're having 2 divided by. Remember, I said in hyperbola, we're going to get this division expression. So 2 divided by x plus 1. 2 divided by x plus 1. And then on that expression, you add 3. So it's 2 divided by x plus 1 all plus 3. So then when you look at the value of a, it is 2. And 2 is bigger than 0 because we know that 2 is positive. So once you see that, already you know that your hyperbola parts will be in quadrant 1 and quadrant 3. Q, it is equals to 3. Q, it is equals to 3. And remember, Q represents the horizontal asymptote. So then you are going to have the horizontal asymptote at y is equals to 3. You are going to have the horizontal asymptote at y is equals to 3. So meaning you are going to go to your Cartesian plane, and then at y is equals to 3, you are going to have your line, your dotted line, which is horizontal. Now, P, because now we have x plus 1. Remember, for us to find the vertical asymptote, we don't just take it as we take the value of the horizontal asymptote, but then we solve for that x. We equate to 0 and solve for that x. So then we are going to have x plus 1 is equals to 0. So x is going to be equals to negative 1 when you transpose it. So we are going to go to x is equals to negative 1 on your x-axis, and then from downwards to upwards, you are going to draw your dotted line, which is your vertical asymptote. So then I'm trying to give you an idea as to how then do you simplify this. Of course, the graphs have y and x intercepts. So I'll explain them when I explain the part of questions. Now I'm just giving you an overview, which is important, because now if you're having an idea that you're dealing with in terms of your x and y intercept, it will be simple now. As saying, you are going to have a hyperbola which will be on quadrant 1 and quadrant 3, because now the value of a is 2. The horizontal asymptote is going to be at 3. Remember, horizontal asymptote must cut the y-axis, so its equation will be y is equals to 3. Vertical asymptote, it will be x is equals to minus 1. It should cut the x-axis. One important thing that you should remember, it is that when now our graph has moved vertically and horizontally because of the asymptotes having shifted, we take now our quadrants from the asymptotes. So then we consider our asymptotes as our new Cartesian plane. Please remember that one, that when we are dealing with a hyperbola, we take our asymptotes, those dotted lines, the vertical and the horizontal asymptotes, as our new Cartesian plane. So then the quadrants move according to where your asymptotes are. So your quadrant 1 might be part of quadrant 2 on the original Cartesian plane. So I will hope that you are understanding me. Another example which will help you understand me further. Suppose we are having y is equals to negative 5 now. Y is equals to negative 5 divided by x minus 2. The whole of that, you minus 1. So then it's y is equals to negative 5 divided by x minus 2 minus 1. So then a, the value of a is minus 5. Remember, a, it is your numerator. Now you know that when a is minus 5, you are going to quadrant 2 and quadrant number 4. Q, your horizontal asymptote is negative 1. So you are going to go to negative 1 and then draw a horizontal line across. And it should be dotted. Do not forget that one. X, the denominator is x minus 2. When you solve for x, x minus 2 is equals to 0, x is equals to 2. So then you know that your vertical asymptote, it will be at 2 for that one. So then hyperbola, it is not that quite complex, but it has a lot of work to do. So hence I'm giving you this overview so that when we discuss now your y and x intercept, it will be simple. Parabola. Remember I said parabola, it is that one which takes the rainbow shape. The shape of the rainbow, yes. It's an arc. Parabola is an arc. So The standard form of parabola is y is equals to x squared plus bx plus c. X squared plus bx plus c. As in hyperbola and in exponential graph, the value of a, it tells us about the shape. When a is bigger than 0, meaning when you have a positive number as your a, your parabola is going to face upwards. Your parabola is going to face upwards. Your parabola is going to face upwards. And then when a is less than 0, meaning when a is negative, your parabola is going to face downwards. So then if you have something like y is equals to 2x squared plus 3, the coefficient of x squared is 2. You know that you are dealing with a parabola that is facing upwards. It's like a rainbow that is facing the sky. Now, if you're having y is equals to negative 3x squared plus 4x plus 6, the value of a, it's negative 3 for that one. You know that you are dealing with a parabola that is facing downwards. I would hope that we are still together on that one. Now, b, the value of b helps us to get the turning point. No, the turning point, sorry, it's not point. The value of b helps us to get the turning point. How so? We are having a formula of x is equals to negative b over 2a. Remember that formula, we learned it in grade 11. Negative b over 2a. So then, if we use that formula, we get our x coordinate of the turning point. Because now, the rainbow, remember the rainbow, when we were young, we used to chase it and then would get to a point whereby we can see it clearly. It will go from downwards, upwards, and then come here downwards. So the highest point is what we call the turning point. Now, if you can take it and then invert it, make it face the sky instead of the F. At its lowest point, again, now B has what we know mathematically, that a point has a set of coordinates. It has x and it has y. So then, when we want that point whereby our graph will be turning either from upwards to downwards or from downwards to upwards, we should use the formula of x is equal to negative b over 2a. X is equal to negative b over 2a. So then we'll take our value of b and then substitute it, and then take the value of a, which I had already explained that it tells us about the shape. Substitute it into the formula of x is equal to negative b over 2a to get what we call the x coordinate. Now that we are done with the x coordinate, we should then discuss the y coordinate. How do we get the y coordinate? We substitute the x coordinate, meaning what we got when we use the formula of negative b over 2a, into the original formula. So then, if, for an example, you are having x squared plus 6x plus 5, x squared plus 6x plus 5. You know that you are dealing with parabola because you are having x squared now. Now, for you to get the turning point of this graph, your value of b is 6, because now you are having, remember that one, x squared plus 6x plus 5. Your value of b is 6. So then the formula is negative b over 2a. So you're going to take that 6 and then put into b. So you're going to have x is equal to negative bracket of 6 close bracket, all divided by 2. The value of a is 1. You substitute 1. So then this will give you negative 6 divided by 2 times 1, which is negative 6 divided by 2. The whole of that will give you negative 3. It means then this parabola, when it gets to x equals to negative 3, it is turning It is its turning point. But I said a point should have the corresponding y value. You are going to take that -3 and substitute it into your original formula of your graph, which was what? Equation of your graph, which was what? X squared plus 6x plus 5. When you see x, you put -3. So you are going to have -3 squared, which is inside the bracket. Remember that one, plus 6 multiplied by -3, all plus 5. This will give you, if my mathematics says me right, -13. So then add -3 is to -13. Your graph will be taking a turning into C. What does C represent in a parabola? Remember I said the equation was ax squared plus bx plus c, and I have already explained the variables a and b. C represents the y-intercept. C represents the y-intercept. So then this is where your graph will be cutting the x values. This is where your graph will be cutting the x values. This is where your graph will be cutting the x values. I want to put a correction on that one. The y coordinate for the turning point is not -13 but -4, guys. Okay, I hope that we are still together. Now, part 4 of our lesson, which is the most commonly asked questions. The most commonly asked questions. These ones are questions in maths. And then on these questions, this is where you should collect your maximax. These questions will always be there. So it's where you should collect maximum marks. Number 1, the low order questions. Finding x and y intercept. Remember, a graph can cut, and in most of the cases we tested that one, can cut the x and the y intercept. Now, how do you find this? And these questions apply to all your 4 graphs. Remember, for you to find the x-intercept, the x-intercept, it is whereby the value of y is 0. Same as when you have to calculate the y-intercept. The y-intercept, it is whereby your graph, your x value is 0. And I said to you, it applies to all the graphs. Let's say we're having a straight line, 2x plus 6, and then we want to draw that straight line. Okay, the value of gradient is 2. Now, I had already explained that when m is positive, gradient, when m is positive, meaning when it's having a positive gradient, it's going to increase. So then, if you want, for that straight line, g of x, and remember, g of x represent y, 2x plus 6. If you want the x-intercept, where you see y, you are going to put 0. So then you are going to have y is equal to 2x plus 6. Where you see y, you put 0. So then this is going to give you 0 is equal to 2x plus 6. This is question 1 stuff, guys. So then you are going to have to transpose that 6. It's going to give you -6 is equal to 2x. You divide everything by 2 on both sides, and then you're going to get -3. So it means that the straight line, as it increases, it will cut the x values at x is equal to -3. So finding x and y intercept, it has got to do with paper 1. No, with question 1. What is important is for you to have a basic understanding that when you want to solve for the x-intercept, where you see y, and this y, it's where in your equation we give you as g of x, k at x, and all of that, you put 0 and then solve for x. But then when you solve for y, where you see x, you put 0. I would hope that we are still together. And quite importantly, this question applies to all the graphs. So this is the first low order questions which we should grab maximum marks on. Number two low order question. Writing down the equations of asymptotes. Remember, only exponential and hyperbola has asymptotes. Starting with exponential graph. Exponential graph only has one asymptote, which is horizontal. It must be clear. Exponential has only y asymptote. And then where is that horizontal asymptote? Or how do you see it? Or how do you know it? It is the value of q. So then if I give you an equation like g of x, remember that g of x is y. Yes, g of x is equals to 4 to the power of x plus 2. You know that your horizontal asymptote is 2. But the mistake that you are doing, it is that you guys will say q is equals to 2. We didn't say give us the value of q, but rather we said write down or give us the equation of an asymptote of this exponential graph. Now, when we are dealing with an equation in terms of asymptote, it should start with either y is equals to or x is equals to. And then if it's horizontal, you start with y is equals to. Okay. The second graph which has asymptote, it is your hyperbola. The second graph which has your asymptote, it is your hyperbola. So then if you are being asked to give or to write the equations of asymptotes of an hyperbola, remember, horizontal one, it should always start with y. Vertical one, it should always start with x. For an example, you can have 3 divided by x plus 2 all plus 1. If I may repeat it, 3 divided by x plus 2 all plus y. And then your horizontal asymptote would be, the equation would be y is equals to 1. Remember, it's the value of q, you take it as it is, but then you write y, because now we're talking about an equation. Y is equals to 1. In terms of the vertical, I want to repeat it. We are now saying x is equals to. So it will be x is equals to negative 2. Because now remember we had solved for x plus 2 is equals to 0. So x is equals to negative 1. So that is number 2 in terms of the low order questions. Remember, number 1 is finding the x and y intercepts. Number 2 is writing down the equation of asymptotes. Number 3 in terms of the low order questions is having to know or to determine the domain and the range of each and every graph. Domain and range applies to all the graphs. Now, domain, it is where your graph or your function exists in the x values. So we're talking about the x element. Range is where your graph exists in the y values. So we're talking about the y element. Now, in a straight line that is not restricted, meaning a straight line which has arrows at both ends, the domain and range, because now arrows means the straight line will continue. The domain and range, they are simply x an element of real numbers. That applies also to your parabola, but only domain. If your parabola either facing upwards or downwards, arrows on both ends, because now it exists everywhere in terms of the x values. We just say x an element of real numbers. But then when you have restrictions, you've got to write them down. I mean, a parabola which is facing downwards and turning at, for an example, having a turning point as at 2:5. It means then that parabola, when it gets to, so then its range will be negative infinity to positive 5. Or you can simply say x is less or equals to 5. So then I want to raise awareness here, guys, to say now in terms of domain and range, they apply to all the graphs. But then you must go and look again, because now if you have restrictions, you can't just say x an element of negative infinity to positive infinity. No, it won't apply like that. I'm running out of time, and I'm trying to be very quick on this one. But don't worry. Again, Mr. Mko will come and address functions when he comes. Part 5. Part 5 now, it is your complex questions. These are middle order to high order questions. Number 1 of those, finding the average gradient. Now, how do you determine or find the average gradient? We are using the formula of the actual gradient. Remember, m is equals to y2 minus y1, all divided by x2 minus x1. And then on the concept of finding the average gradient, it can be asked on one of your functions. And then in most of the, if not all, we're going to give you 2 x values. And an example, we can say if plus 2, x squared plus 2, x squared plus 2, and then find the average gradient between x is equals to 1 and x is equals to 3. Now we're giving you 2 x values, which is x is equals to 1 and x is equals to 3. Now, yours is to find their corresponding y values. How do you do so? You take the first x value, which is 1. You substitute in your equation. Remember, it applies across the board. And then when you substitute it, in our equation we're having, or in our graph we're having x squared plus 2. You are going to get 1 squared plus 2. This will give you 3. So when x is 1, y is 3. Now you are having the first point. You repeat the same process, taking the x value now, number 2, which is 3. So then when you substitute it, you are going to have 3 to the power 2, which is 9, and then you add 2 to it, which is 11. So then you are now having the second point. You are going to use the current formula. From the current formula, you are going to say now 11 minus 3, which are your y values which you found when you are calculating them. Minus 3 minus 1. The average gradient will be equals to 4. So average gradient applies across the board. You are going to be given 2 x values. You substitute the first one to get its corresponding y value, the second one to get its corresponding y value. And then you use the formula of gradient to calculate the average gradient.
Nesentse ile yena Mr. EK Nkumbi yena sentse tlile ka kwano a re fa pampiri ya mathematics ya grade 11. Wena mamedi wa ka ke tshepa go fela so sokola ka tsona, ke tshepa gore menere ka kwano o le thusitse. Menere, just share your final words and say your goodbyes there.
Okay. I'm not a fan of this, my host, because it has got a lot of scope. But if you can just round it up, you also have to know, in terms of high order and middle order questions, you also have to know how to calculate the distance between the 2 points. They can be horizontal, vertical, or they can be the distance between the 2 graphs. I was going to explain that one. You also have to remember, guys, how to calculate the coordinates of the point of intersection between the 2 graphs. Now, my last words are, this topic, functions and graphs, we don't teach it in grade 12, but it is tested on your paper, June, trial, and final. So then, where I didn't get, or where I didn't reach, Mr. Mukong is going to come back. And then I think I'm going to come back again after 3 days. So if my beautiful learners has questions, they can always send them in a group. I will address them when I come back, before I do the next topic. So please, guys, during these difficult times, keep on practicing. Thank you.
Thank you, sir.
103.